A car moving with a velocity of 20 meters per second saw a crowd of demonstrators. When the car was 120 meters away from the crowd, the driver applied the brakes and the car decelerates at 2 meters per second squared. Determine whether or not the car hit anyone in the crowd. So always try to picture the incident or the event in your mind so that you can get the concepts right before you go into the mathematics, because I've said that physics has to do with understanding concepts and then expressing the concept in mathematics. So we have a car traveling at velocity, at initial velocity 20 meters per second. Then it saw some demonstrators 120 meters away from him or her. Then it started to decelerate. Decelerate means that the speed started to reduce at a rate 2 meters per second squared. So we have to determine whether or not the car hit anyone in the crowd. So this tells us that the 120 here is a reference figure. So you are going to find another distance. If the distance is equal or more than 120, it means that the car hit someone in the crowd. If the distance we are calculating is less than 120, it means that the car was able to stop before it gets into the crowd. The assumption here is that the demonstrators are not moving any further towards the car. They are at the point where the car first saw them. So as I always say, the first thing you need to do is to extract your data. So let's extract our data from the question. The first information I can get out of this is my initial velocity. So initial velocity of the car is 20 meters per second. Then acceleration. The acceleration, the question mentioned that it was decelerating, and decelerating means that our acceleration is negative. It is slowing down, so it is negative acceleration. So negative 2 meters per second squared. Then, as I said in one of my videos, that sometimes some information will be embedded in some phrases or will be hidden until you use the understanding and the concept to get it out. Now, these are the information we have. What other information can you get out of this? Before we will know whether the car have hit anyone, the car might have come to a stop before we can make that determination. So if the car have stopped, it means that the final velocity of the car at that point is 0 meters per second. So in determining whether the car hits anyone in the crowd, we need to know the distance it covered after it started to decelerate. So this is the data I can get out of the question. So the next thing is to check. In fact, of course, my units are okay, my SI units are okay. Using my SUVAT, the missing variable consonant here is T, because S is there, that's what you are looking for, and then V is also there, T is missing. So since T is missing, we are using the third equation of motion. So the third equation of motion also says that V squared is equal to U squared plus 2AS. So you can decide to make your S the subject, or you can decide to substitute directly. So I always prefer to substitute, because if the change of subject don't go well, then I am in trouble. So to substitute, I know my V to be 0 squared, and then my U is 20, then plus 2, my acceleration is negative 2, and then S, which I am going to determine. So I have 0 equals to, 20 is 20 squared, so 0 equals to 400 minus 2 times negative 2 is negative 4. So minus 4s. I'm looking for s, so I make s the subject. So I send minus 4s to the other side of the equation, and I get 4s to be equal to 400. So I divide both sides by 4 and divide here by 4. So this simplified will give me s to be equal to 100 meters. So the car stopped at 100 meters. So at 100 meters, let's assume this is 100 meters at this point. The car was able to stop. So did the car hit anyone in the crowd? No, no one in the crowd was hit because the car stopped before it got to where the demonstrators are. So what if the car was originally traveling at 60 meters per second? So what if the initial velocity of the car was 40 meters per second? Will it be able to stop? Now let's verify that. If u was 40, it means that we are going to get 0 squared to be equal to 40 squared plus 2 bracket minus 2s. And that is going to give us 0 to be equal to 1600 minus 4s. So I group like terms. 4s equals 1600 or 1600. I divide both sides by 4 here by 4. So 4 will take care of 4, and I get s to be equal to 400 meters. So it means that if the car was originally traveling at 40 meters per second, it will only be able to stop at 400 meters. So the distance between him, the car, and the demonstrators too is 120. So what do you think? It will run over a lot of people. In fact, it will kill everybody. So this is why we should always travel at reasonable speed when we are driving, so that when there is an emergency, you would be able to stop at the right time, at the right distance.